Hello everyone, welcome back to my channel Data Science using Python. In this video, we will learn about data preparation methods. First, how to add an index field using Python. Steps to add an index field. First, understand the index field. It is a unique identifier for each record in a dataset, commonly a sequential number. Second, choose dataset. Select the dataset, table, spreadsheet, or database where the index field is required. Third, add field column. Spreadsheet example Excel or Google Sheets. Insert a new column and populate it with sequential numbers. Use drag fill or formulas like row minus 1. Database. Added column using SQL or database management tools. Fourth, ensure uniqueness. Verify that the index values are unique across all records. Automate. It is an optional thing. First, auto increment setting in databases for dynamic index assignment. Second, apply formulas or scripts for automation in spreadsheets. Sixth, verify. Ensure the index aligns correctly with the data and does not disrupt relationships in the dataset. Seventh, save the changes. Update the dataset with the new index field securely. Let's understand with the help of a code. First, import library. Then we take the sample dataset, which has name and a score column. Next, add an index field starting from 1. Print the dataset. Let's run this code. Here you can see in the output, we get the name column, score column, and the index field. Next, how to change the misleading field values using Python. Steps to change misleading field values. Identify misleading values. Locate fields with incorrect, inconsistent, or ambiguous data. Define correct values. Determine the accurate or standardized value to replace missing ones. Filter data. Use filters or queries to isolate records with misleading values. Update values. Manual update. And the second is bulk update. In manual update, edit individual records in spreadsheets or databases. In bulk update, use find and replace or SQL update query for large data sets. Fifth step, ensure consistency. Align updated values with data standards or domain rules. Sixth, document changes. Keep a record of update for transparency and reproducibility. 7. Verify results. Review the dataset to ensure updates were correctly applied and no errors were introduced. 8. Prevent future issues. Implement validation rules, drop downs, or automated checks to maintain data integrity. Let's understand this with the help of a Python code. How to change misleading field values. Replace a misleading field value. In this data set, we have the misleading field values unknown because unknown is not a name of a person. Data set has an unknown value and the score. We have to replace the unknown value with which is not provided with the not provided one and display the updated data frame. Let's run this code once again. As you can see in the output, in place of unknown, we have updated the value with not provided. Okay, let's understand the next topic. How to re-express categorical field values using Python. Steps to re-express categorical field values are: first, understand re-expression. Modify categorical data to improve clarity, consistency, or analysis. Second, identify fields. Select the categorical fields needing re-expression. Third, define mapping rules. Create a clear mapping of old values to new ones. Consider consolidating similar categories or renaming for better comprehension. Fourth step, apply changes, manual update, and bulk mapping. There are two types of changes in this. Directly edit the value in the small data set, and bulk mapping. Use tools like tool lookup tables, formulas, or scripts in spreadsheet or databases. Fifth, automate is an optional step. Use conditional logic or SQL case statements for systematic re-expression. Sixth step, validate changes. Ensure updated values align with the intended meaning and data consistency. 7. Document process. Maintain a record of the old to new value mappings for future references. 8th step. Review results. Check the transform field to verify correct implementation. Let's understand this with the code of Python. First, we take the sample data frame, which is name and a grade column. Map grades to description. Grades, we can describe the grades like grade mapping. A means excellent, B means good, and C means average. Display the data frame. Let's run this code once again. Alice got grade A means excellent, Bob got grade B means good, and Charlie got grade C means average. Let's understand the fourth data preparation method. How to standardize numeric fields using Python. Steps to standardize numeric fields. Understand standardization. It involves transforming numeric data to have a mean of 0 and a standard deviation of 1. Second step, identify the fields. Select the numeric fields requiring standardization. Calculate matrix. Compute the mean and standard deviation sigma of the field. Apply standardization formula. For each value, calculate the standard value as z is equals to mean x minus mean sigma. Then the fifth step, transform the value. Replace original value with their standardized counterparts or store them in a new field. Sixth is an optional step, which is automate. Use software tools, example Excel, Python, Sklearn, or SQL to perform the transformation efficiently. Seventh step, verify result. Check that the standardized field has a mean close to 0 and a standard deviation of 1. Next step, document process. Record the original mean and standard deviation for reproducibility. Ninth, apply where needed. Use standardized values in analysis requiring normalization such as clustering or regression. Let's understand this with the code. How to standardize numeric field values. First, we take the sample data frame, which is Alice, Bob, Charlie, 85, 90, and 95 are their scores. Standardize the score column. Then display the data frame. Let's run this code once again. Next, we learn about how to identify outliers using Python. There are the following steps you can use to find the outliers in Python. Understand outlier, data points that are unusually high or low compared to others. Second, import libraries, use pandas for data, numpy for calculations, and matplotlib for plots. Third, load data. Import your dataset into a pandas data frame. Fourth, method to detect outlier like interquartile range. And the another method is z-square. Next method is visualization. Use box plots or scatter plots to see outliers. Apply in Python. And next step is verify. Review the identified outlier for accuracy. Let's understand with the code. we take the sample data frame. As you can see in the example, the score of the score of Alice, Bob, and Charlie are 85, 90, 95. They are below 100, and the score of David is 150. It is an outlier. First, calculate the Q1 for 25th percentile or Q3 for 75 percentile. Let's calculate the score, then calculate the interquartile range IQR. Define the lower and upper bounds of outlier. Next, identify the outlier and next display the data frame. Let's run this code once again and see the output. Name Alice, Bob, Charlie, David. Which is the outlier? David is the outlier. As you can see in the score column, 150 is an odd value and it is an outlier. So that's it for this topic. We will meet in the next video.